Today in Algebra 2, we are going to begin talking about function operations. So you are going to take these notes in your notebook. So over the course of the next 2 days, we're going to talk about some things that I think you will be pretty easy, and then we're going to kind of move to a little more difficult level tomorrow of how do we take different functions and put them together. And so there's essentially 5 things that we're going to do. We are going to add, we are going to subtract. That's not going to be too hard. We're going to multiply and divide to make new functions. And so those are operations that you've had experience with before, and those are the things we're going to do all today. The last thing I'm going to reserve for tomorrow, and that's called a composition, and that's when we actually take a function and we put it inside of another function. So let's first talk about, we're going to use just a couple examples, addition and subtraction of functions. The first thing I want to introduce to you is the notation in which you're going to see these. So at this point, you've seen something called function notation, okay? F of x is just how we typically write function notation. And if we put specific values in here, like a 9 or a 2, that just tells us we're gonna, in a function, take out the x and replace it with that value. So the notation for addition and subtraction is gonna be written one of two ways. You'll either see it written as f plus g of x, and that's not a multiplication symbol. This is telling you your new function is made up of these added, or you might see it as a subtraction sign. Or another notation, I tend to use this first notation more often, that you might see is f plus or minus g, and then this open circle. It's not a multiplication sign, it's a little open circle of x. And so if you see either of those things today, that's going to tell you, hey, you need to add those two functions and put them together. Sometimes the functions have like terms and sometimes they do not. So my example for this is, suppose I had the functions (3x plus 4) and g of x defined as x squared minus 5x plus 2. And I asked you to find the function, f plus g of x, and then I'll write them in both ways. And then how about we'll go in g minus f of x. So just practice with both different notations. All right, so for this first one, I literally am going to add 3x plus 4 plus x squared minus 5x plus 2. At that time, what we're going to do is add any like terms that we have. And so I can put this 3x minus 5x together, and this 4 and 2 together, and that would leave me with x squared minus 2x, because 3x minus 5x is negative 2x, plus 6 is my new function for f plus g of x. All right, for our last one, for g minus f of x, we want to make sure that we subtract the entire function f from g. So we're going to be subtracting both the 3x and the 4. So we have x squared minus 5x minus 3x, which would give us minus 8x, plus 2 minus 4, which would give us the new function x squared minus 8x minus 2. And so I really kind of consider today like just a change maybe in notation. If you've added functions before, you subtracted functions before. How do we multiply and divide functions? Honestly, if possible, the notation looks really similar. So we set up here the notation, and I'll just maybe put a box around it. Those notation things are something that you're going to want to have a quick eye to go to today. For multiplication and division, it's very similar. It's either f, that's times g of x, or f times g along with open circle x. That's how you would write multiplication. And then division would be f divided by g of x. Or it could also be seen this way. And so just be careful on the worksheet that you see today, not or, along with, that you might see it written in either way, and what that means is to multiply the two functions or to divide the two functions. Okay, so if I just kind of put some together, I'll do some maybe with some numbers too, so you can see what that looks like. Suppose I had the function f of x equals 2x minus 1. And g of x equals 3x minus 2. And I asked you to find f times g of x. And then I ask you to find f times g, let's do a specific value, of negative 2. So we first want to just take our functions and write 2x minus 1 times 3x minus 2 would be the most basic. This is something we know how to multiply, so I would need to multiply everything in the first parentheses by everything in the second. If I did that, I have 6x squared. I'm going to do this part in my head. Minus 4x minus 3x are like terms. And then we have plus 2. Now, when you're doing a specific value, here are your choices. You can either put negative 2 into f and then into g and multiply them together. I'm going to show you how that works. So I'm going to show you how it works in both. If I put f of negative 2, that'd be 2 times negative 2 minus 1. That's f of negative 2. And then g of negative 2 would be 3. Now, we're not going to get overwhelmed by this. We're going to just simplify. I'm just showing you my work. Negative 4 minus 1 is negative 5. And negative 6 minus 2 is negative 8. And negative 8 times negative 5 is positive 40. What I want to show you is that you should get the same thing if you plug negative 2 into your simplified function. So if I did that, I'll just show it on my calculator for time. You see that I also get 40, the same thing. So those are your two options when plugging in a point. All right, suppose I ask then, same functions, for you to write a function f divided by g of x, and then let's do f divided by g of 1. This is just how it seems, and I'll tell you, like, a lot of times this is the easiest one because there's not a whole lot of simplifying that happens. So I literally going to put the function f and I'm going to put it on the top, so 2x minus 1, and the function g and put it on the bottom. Okay. The only simplifying we're ever going to be able to do is if, like, I factor things such as I did in chapter 4 and cancel things out. Otherwise, we're going to just have a fraction form of our function. Please hesitate from doing things where, like, you can't cancel these 2's out. That's killing cats. We've talked about that before. Just a word of warning. The function, when you divide them, sometimes there are excluded values, just so you're aware of that. So this one would be an excluded value of 2/3 because that would make the denominator 0. If I ask for specifically, you're probably actually going to see parentheses around this, f divided by g of 1, again, that doesn't mean multiplication. That means you're going to take the division and plug 1 in for x. So taking my function, that's 2 times 1 minus 1 over 3 times 1 minus 2. 2 times 1 minus 1 is 1. 3 times 1 minus 2 is also 1. This one simplifies to just 1. All right, so tomorrow, just leading up to tomorrow, we're going to talk about how, if you have two functions, you can take an entire function and put it inside the other function, which is a whole separate thing. But today you're just going to be asked some questions by addition, about addition, subtraction, multiplication, and division.